Hi everyone, my name is Javier Donoso. Thanks for being here and watching this video. We're gonna walk through a blog post I'm about to publish explaining how to easily integrate the Gelato network in our smart contracts. What is the Gelato network? The Gelato network allows you to automate some tasks in the future. As we all know, we cannot schedule any kind of method call in our smart contracts. The Gelato networks help us exactly to overcome this problem. It means we will use the Gelato network to call a function, a method, in a future point of time. Why I'm doing this? In the last weeks, months, I've been heavily participating in hackathons and working and building on with the superfluid protocol. The superfluid protocol allows users to stream money and tokens to other users or contracts with only one transaction and minimal capital lockup. The problem there is that the stream will not stop until you stop it yourself. And in the case that you forget it, it will stream infinitely and it will drain your tokens and your money. Therefore, I think it would be fantastic to have a very simple guide how to integrate Superfluid protocol and the Gelato network. We have already built a DApp and is deployed, and we have two contracts that we will interact with, and they are verified on Moonbay. You can see the code here of all of the project, but before we jump into the demo, let's see what are the 3+3 steps that we need um, to but before, let's see what are the 3+3 steps that we need to gelatify our smart contract. The Gelato network has three main contracts: the Ops contract, Operations contract, the Gelato Treasury contract, and the Gelato network. The Ops contract will be our main contract, will be the main contract with which we're gonna interact. Um, we're gonna create the task, transfer the fees, we're gonna cancel the task, and we will need to inherit a so-called ops-ready.sol, and we will request the interface of the eOps and eTask treasury to make our smart contract able to talk to the Gelato network. In the constructor, we will have to pass the ops address and the treasury address. Um, in our repo, the link is here. You can see these files and you can simply copy the files and embed and include in your project. Um, with the Gelato Ops contract, we will always need to interact. With the Gelato Treasury contract, we will only interact in the case that we choose a specific funding strategy. We will see that later. And the Gelato Network contract, we are only going to interact when we are going to do the test. We're going to see this in the bonus track number 2. Now, the Gelato funding strategy. The Gelato funding strategy, we have two ways of funding our transactions. Remember that Gelato will automate our task and will call a method in the future. It means it will do a transaction in our behalf. It's clear that someone has to pay for this transaction. And Gelato offers us two ways. The first one is to fund the so-called treasury contract. We can send funds to this treasury contract, and then every time Gelato do a transaction in our behalf in a future point of time, it will take the fees from this amount funded. We can for sure withdraw the contract too. We can do a withdrawal of the contract too. The other way to fund our transactions is every time that the executable transaction will happen, we will transfer the fees to the Gelato network. It means we don't have a kind of buffer with in the treasury as we had before. Here we're gonna pay for each and every transaction. The fees are going to be taken from our contract. It means that we must ensure in this, if we choose this strategy, that our contract has to have funds. The third step is the one we're gonna invest more time. And here is the business logic that we are passing to the Gelato network to create, check, and execute the task. And we call it 3 plus 3 steps because in this third step we have 3 additional steps. The create, we are going to create a task and we're going to pass several params. The first one is the address of the contract that we want to execute, which function we should execute. This is the start party selector. And then we have to pass the resolver contract and the checker function within the resolver contract that will tell Gelato whether this function can be executed or not upon certain conditions. In our case, the resolver contract is the same as the smart contract. That's why we are including the address this the same as execute contract. What we see here is in the fourth line, we are passing the condition, which is the this checker start party selector. It means we are passing within the create task the function that will check whether the task can be executed or not. And this is our second step of the business logic. We have to create the checker condition function. The checker condition function will return and can exec boolean that will tell Gelato whether can be executed or not, and the payload, which is a bytes memory, with the encoded executable function. We see it here is the same as the contract will execute. And the third step within the Gelato business logic is the executable function itself, which can only be called by the ops contract and will execute our logic. Here we can see the full code of this use case. Now Now let's go to our demo. We have demo two contracts. One is the so-called Party App demo, and the second one is the Super App Superfluid demo. The Party App is a very simple app. It allows us to start a party every time that we don't have a headache. And therefore, we're going to tell Gelato, please check whether I have a headache or not. And in the case that I don't have a headache, start a party. Let's go to our app. Here we see our screen, our party app contract. So far we have 0 ether. We don't have balance. This icon, it means that I have a headache. It means that if I try to execute a task now, Gelato will check in the can exec function whether I have a headache or not. And because I have a headache, it won't start a party. On the left-hand side of the screen, we're going to use the funding strategy with the Gelato treasury, and on the right-hand side of the screen, we're going to pay for each transaction. We're going to demo the first use case is a simple task that will check whether I have a headache or not. I'm going to fund the treasury contract. Now, it was a problem with the RPC network. That's why I did the request 2 times. Now I'm going to start a task. With the code we just saw before, we have to confirm that we're going to start the task in Gelato. Perfect. Task has been created. And now if we go to the Gelato Ops network, here is the task with the address I'm logged in. As the contract is the one creating the task, we cannot see the task here. Therefore, we have to go to the leaderboard and we search upon the task ID or the contract, and we have found this one. And here we can see our task. We are on Monday. We see that the automated function is the start party, and the checker function is the checker start party. Um, Remember that we are interacting with the blockchain. It means that although we think that in Web2 the schedulers are at the time, exactly time point that we want, when the executors are going to pick up the task and execute it. So far is no executions. However, the task cannot be executed because I'm still with a headache. I can change this, clicking here and converting and telling my dApp that that headache is over. Okay, you see, I have a fantastic face. It means that I don't have any more a headache. And now we should wait when the Gelato network takes the task and executes it. And then if we go to our contract, we will see that he's going bigger, that he's going to check whether the headache present is true or false, and in the case, then it will execute, it will change the last party star to right now, and it will change the headache present to true. Okay, let's go. Let's see when the Gelato network is going to execute. Now we see that one execution has already happened, and we can see here with the status succeed. Then if we go towards Gelato and we refresh the state, we see that the last party's start has changed and we have a new headache, and our treasury has decreased a little bit more. Okay, the task is still there. It means that if we tell our dApp that our headache is finished, then in the next possible block, we will have Gelato will again execute the function. Now some time has elapsed. Let's see, we have already two executions. And if we go to our dApp and we refresh, we see that our last party has started 4 minutes ago, and we have again a headache. Okay, as this task will infinitely running, we will cancel ourselves. Then we cancel the task. Now we can see that we don't have a task ID. And if we go to the Gelato ops, we will see here, if we refresh, that our task is paused. Therefore, it's not going to execute the next time we change our headache to true. Now, let's go to see a little bit how the code is structured. In our contract, as I mentioned before, we have to inherit the ops ready contract. The ops ready contract is a very simple contract with some transfer functions and with a modifier. We also have the interface of the task treasury and the ops contract that we can simply copy in our contract folder and then inherit import in our party app, and that's it. We will only need to pass the address of the ops and the treasury in the case that we choose the funding strategy with the Gelato treasury contract. And then here we have some admin functions, cancel, withdrawal, and here is how we create the business logic of our task. Remember, we have these three steps in our third step: create task, checker function, and executable function. This one is the one we just saw, and now we're gonna see another use case, which is that when the task is executed one time, it will, in the same executable function, cancel the task. This pattern will help us to only execute once one task. And it will, for the superfluid application, is for utmost importance because we would like to stop the fluid one time in the future, but once the stream is stopped, we won't request this task again. Then let's see the demo. We are still on the left hand side. We are still on the left side of the screen, and it means that we're gonna work with the Gelato treasury. Okay, we're gonna start a task, and it will be cancelled after the first execution. The checker function is still the same. It will check whether we have a headache or not. Okay, we're gonna start the task. And we can have a look into the code. So far is the same as before. We have the address of the contract, we have the selector of the function that is going to be executed, we have the address of the resolver contract, which is the same as our contract, and we have the encoded selector of the checker function. In this case, we are gonna pass the sender because we will have to cancel the task later on, and we will request the address of the sender who started the task. Here we have the checker cancel that check whether the headache is present or not, and it will encode the payload. It will return the payload with the selector of the executable function and again the user as a param. And then when we have our executable function, we'll check which was the task ID of this specific task. It will cancel the task. It will change the last party star time to right now, and it will say that headache is present. Let's gonna see. We're gonna copy the task ID. We're gonna go to our leaderboard. Here we can see our task. As you can see, start party and cancel. Check a cancel. It will be paid with the account funds. It means the contract, the funds that are deposited on the Gelato Treasury contract by the smart contract, not the account funds. So far, nothing is there. Well, it looks like the execution has already happened, and we can already see that the task has been paused. It means that when we have executed the task, we have already paused the task. Perfect. Let's go to our contract, and we see that it has changed when the last party was started, and we have already a hit. Okay, we're gonna change it again. Now, the third use case that we're gonna see in our party app is actually the same as the first one, but without using the Gelato treasury. It means paying for every transaction. And we can do that by funding our contract. We can fund our contract directly, like this, or we can pass Ether value in our function call. As we already have funded the contract, we won't need it. Then we start the task with no prepayment. Actually, the workflow is going to be really the same. If we go now to the code, we're going to see this one. This one is the create a simple task with no prepayment. So far, the first part is the same. The only thing is that we have to pass the fee token when we create the task. It means we say that we're gonna pay with Ether. This Ether is defined in our ops ready contract. Here we have it. Then the same for the checker function, actually is the same logic as before. And where it's something changed is in the executable function, because here we have to transfer the fees to Gelato, and then we call the git fee details in the ops contract. Then we receive the fee and the fee token, and then we simply transfer from our contract to the fee token to the Gelato network, and we change when the last party start was started, and that we have a headache as the same as before. Okay, then let's go copy the task ID, go to the Gelato network, go to the leaderboard, copy our task ID, and see that we have again our start party and checker function. Now we can see that our task has been executed. Perfect. And we also see something different as before, and here it's stated that we're gonna pay with contract funds, not with account funds as before. Good. Let's see we refresh our DApp. Again, we have a headache. The last party start time changed, and the task ID is still relevant because we haven't canceled the task. Then we're gonna cancel now. And with this, we have already finished the 3 use cases within our party app. Let's going to move to our Gelato Super app. Now, let's go to see the Gelato Super app. The Gelato Super app is the integration between a superfluid super app and the Gelato network. The superfluid super app allows you to interact with your stream. It means it's a smart contract that have certain callbacks from the cash flow agreement from superfluid, and then it means that when you stream to this contract, the contract can receive the stream and do whatever he wants to do with this stream. Can redirect a part of it, can keep it for him, can do whatever he wants with the stream. Then we're gonna stream the so-called fake DAI tokens that we have here. You can easily transfer between DAI and super token DAI. I'm not going to enter very much in detail in Superfluid because I assume that if you are seeing this video, you have already acknowledged in Superfluid and in Gelato. That's why I'm gonna rush a little bit on the Superfluid concepts. Again, we're having the Gelato treasury that we're going to fund. Now we're gonna start the stream, and we're gonna tell the stream to stop in 15 minutes. I have here the receiver with the new fantastic dashboard of Superfluid already ready. Then I'm going to start a stream with the SDK. The smart contract, the super app, will receive the start of the stream, will create a task, and will tell Gelato to stop in 15 minutes. Hopefully it works. Okay, let's check it. Let's see first whether a stream has created and a task has been created. Oh, I see a MetaMask error. Insufficient funds. Okay, maybe it was before. Mm. Okay, I'm seeing that my balance is now changing. It means that the stream has already started. I'm here querying every second the balance of the super token contract. This is not really performant, but I wanted to do to showcase much easily the how it works. If we go now to our receiver, and if I refresh the dashboard, well, I have only to choose. We have Mumbai, and we see that actually we have a stream. We are receiving a stream of $300 a month, and this is the flow rate. I've calculated in the contract the $10 a day. Now let's see. Let's see. We're gonna copy the task ID. We're gonna go to our leaderboard. We're gonna see the task, and let's see, it tells me that it's going to be executed at 20:08. It means more or less 15 minutes as we have as we wanted. Then let's wait and hope that it works. So far, it looks like it's happening as we expect. See you in 30 minutes. Good. Still, we are 3 minutes away from the execution. Let's see if it's still, yes, still is streaming. We're gonna check again. Yes, still is streaming. Let's have a look in our code. Let's have a look in our Gelato Super App contract. As before, we have, wait a minute. As before, we have inherited the ops ready, and in this case, the Super App based from Superfluid. What we can see here is create the stop stream task. The user is not calling this function. This function is called by the callback of the super app after agreement created. Here we can see it. The callback of the super app, take the information, and then create the stop stream task. And in this stop create stream task, we create a time task with the start time of the task, and this one is going to be the duration of our stream, then the interval that we're going to repeat the task. But as we don't want to repeat the task, we're going to because we're going to cancel after the first execution, as we saw before. This is the address of the contract that executes the function, this contract. We have the stop stream function selector is the executable function, the resolver contract, which is the same as this one, and the checker encoded function. We also tell Gelato that we're gonna pay with ETH and that we're gonna use the treasury. Then once it's gonna be the time is gonna check, we're gonna always return true, um, and then um, it has to it has to execute the stop stream function. We pass the sender and the receiver. And this is the stop stream function. Remember that we are working with a super app, which it was receiving a stream from user A and creating a string to user B with the same flow rate. Then we have to cancel both streams. Here are the cancel of the both streams, and we are canceling the task in order that it only happened once. Now, let's see where we are now so far. Is 30 seconds away. In between, let's see what is happening. Ah, no, that was the error before. We don't know why. Okay, then let's gonna live see whether the stream is going to stop accordingly to our task. You see here that we have already again account funds that are gonna pay for the transaction time. This one was a previous test I did. Then let's see our contract is still, it's gonna take some time, and oh, it's a stop. Perfect. It means that probably we have already a second execution. Let's see let's see here if we refresh whether the stream has stopped. We're gonna see only number. Yes, it has stopped. Perfect. And if we go to our Gelato network too, the task is also paused because we can say by stop the stream, please cancel the task. Perfect. Then if we go to our Super Gelato and we refresh, perfect, we don't have any task. Excellent. Then what is our first bonus? Imagine that we want not only to stop the stream at a certain point of time, but we want to start the stream in the future. It means that we can really program a stream. Then first, we're gonna take the receiver, which I will use the same, and I will tell our DApp I want the stream to start in 15 minutes and to stop 15 minutes later. It means the stream will start in 15 minutes and will finish 15 minutes later. How we can do that? We can do that because within our DApp we are using the access control from Superfluid. It means that our user gives our Gelato Super app full authorization to start the stream on on his behalf. That's why the super app will start the stream in 15 minutes. We're gonna do that, and we're gonna be MetaMask is gonna ask us to confirm two times. The first time is the authorize a method for the super app to create a stream in the future on behalf of the user, and the second one is the creation of the task itself. Then it looks like it's about to finish. We can already copy this and go to the Gelato network. Exactly, this is the task that we just exactly, we have the start stream, the checker plan stream, and it's going to be executed in 2026. This use case is interesting because actually we are concatenating two business logic. Here is the one. Actually, we have the first function, which creates the task. This task will execute in the future a start stream. Then we have the checker function. We have the executable function, which start a stream, cancel the task, and at the same time create a new time task, a new use case with a stop stream function. It means it's a concatenation of two use cases. Now some time has already passed, and we see that the execution has happened. It means that the stream should have been started. If we go to the here we can see that our stream has already started in Monday. And actually, if we take the new task and if we go to the Gelato network and we see the new task we just created, we see that in actually 4 minutes is going to stop the stream. Then let's wait. Thank you very much. Now, the task should have been already um, executed. Let's see. Yes, exactly. And our stream should have stopped. If we go to here and we refresh our dashboard, we will only choose Monday. We see that exactly the stream. And if we go the details, we just seen that actually it started in 2026 and it took 15 minutes. Perfect. That is actually what we wanted. Now let's see we refresh our app. Perfect. Nothing more to say. Now let's jump to our post. Here is actually described the different things what we have just taught, and we have a, a bonus track number 2, and that is we are working with what we just saw in the demo app. We were working with the Mumbai testnet, but when we are developing, we need to interact with our local chain. We use a fork of the Mumbai testnet, and we interact with the fork, and we use the different methods like mine a block or jump to another time or different methods we are using. But the difference here is that the Gelato network uses executors to interact with the blockchain and execute the task. And if in our fork we don't have these executors, therefore we're going to use the hard hat impersonate account. And we will impersonate the Gelato network contract. We will take ownership of this contract and we will execute our task. Here is how it works. We impersonate our Gelato network, and later on we can execute the task being the executor, having impersonate being the executor in the local net. And so we can do all of our tests with execution and canceling tasks and everything we need. Well, this is all we wanted to showcase today. Thank you very much for having watched this video. You can connect with me on Twitter, and there are some further reading here. And I say thank you very much, and see you on future videos.